There's debate about whether or not to bond your through-hole fittings and seacocks and things together to a zinc anode or not. One school of thought is that they're dissimilar metals, they're immersed in an electrolyte, you should have them bonded somehow to an anode. The second school of thought is we have hot marinas these days with straight current going through them, and if you bond your through-hole fittings together, you're just providing an easier way for electrons to pass your boat through your through holes and the bonding system instead of through the seawater. So I've devised an experiment that I hope will let me know whether or not it makes sense to bond through holes or not in a hot marina. My experiment is pretty simple. I have 4 glass jars filled with salt water. Over here I have what I'm calling an isolated cove where there's no straight current running through the water. Here I have a hot marina where there's 9 volts of straight current running through the water. In this jar, in the isolated cove, the copper through hull is not bonded to the zinc anode. Here I'm using copper nails and zinc plated screws. Here the copper and zinc are bonded through that bonding wire. This is the recommendation that's made for today, not bonded, for hot marinas. Over here I have the same thing, non-bonded and bonded, but I have my straight current running through that wire, and you can see the bubbles coming up from my electrodes here as the electricity gets pumped through. I know I'm going to make sodium hydroxide in one of these, but hopefully before then I'll be able to measure the mass of the copper nails to determine which copper nails reduced more in the hot marina, and then I'll know whether or not I should bond or not bond. It's only been a few hours, and I'm noticing that in my hot marina with the unbonded through hull and anode, I'm getting corrosion, and the brass, the through hull, bronze, is what's corroding. You can see it down there on the end of that nail, and even the tip of the nail looks like it might have bent. And I see a little green in the foam. Those bubbles are chlorine because I'm conducting electrolysis on the water too, so I'm releasing chlorine gas. Anyway, I realize there's a problem with my experiment. I think both of these need to be in the same container. They can't be in separate containers because right now they're in different aqueous solutions. That's probably getting basic. This is slightly acidic, certainly losing a lot of chlorine. So I'm going to stop and restart. But even after a few hours, that's my first interesting conclusion. I'm getting corrosion on the non-bonded metals in the hot marina. Okay, I've upgraded my hot marina, so now both boats are in the same marina, and I won't be as worried about the impact of the changing solutions on corrosion. And I've put in new anodes to replace the ones that were corroding before. So again, bonded zinc and copper and non-bonded zinc and copper. The weights of the new anodes are the same as the ones before. 8 grams for the zinc, 10 grams for the zinc, 8 for the copper. I'm adding a little seawater. Okay, So everything is submerged, and I expect I'll probably start seeing some bubbles. Yeah, you can barely see them. And again, that's going to be chlorine coming out there, and this will probably be hydrogen bubbling over here. Good. So I have some current. Okay, so we're continuing the test. These guys don't move. These guys wait and see. I'm going to highlight one other possible problem with my experiment, but I'm just going to ignore it for now. And that is the voltage that I'm passing through it. I've got it hooked up to a 9-volt battery, so I'm passing around 9 volts through the solution. But I have my multimeter hooked up. That is submerged. If I take my other electrode on the multimeter and I put it in, depending on where I put it, I get drastically different voltages on my multimeter. Generally negative towards one side, generally positive towards the other side, which I guess makes sense, but the whole thing is surprising. So I think, unfortunately, where things are located relative to the path that the stray current is taking through the marina makes a difference. But nonetheless, I'm going to continue this experiment just to see what happens. After about 12 hours, I had some pretty evident corrosion on this copper that isn't bonded. I have something going on with the bonded zinc. I'm not quite sure what that is. It'd be interesting to, it looks almost like salt. It'd be interesting to see what's going on there. So something is being conducted through these, but these coppers that are bonded, they still look okay. No signs of corrosion. And that zinc, again, looks okay, although there are a lot of bubbles down there. I'm running out of battery power. My bubbling is slowing. So I'm going to replace the battery. And I'm going to redo this hot marina with several bonded anodes and cathodes in different orientations to see if I can get any corrosion on a bonded piece of copper. I want to see if there's any way I can get corrosion. So far, I've only been able to get corrosion on unbonded copper in the hot marina. So it's been about 2 hours since I reoriented my hot marina, and some interesting things are happening. One, I put in a new battery to give me some new electrons. Secondly, I oriented my copper and zinc in the direction of the flow of electrons. So electrons are leaving here and going here. So both of these are oriented along that flow. You can see in this case, my copper is clearly oxidizing, which I guess makes sense because electrons are going here, they're leaving through this wire and going there. So since in the circuit the electrons are flowing this way, that side is clearly oxidizing. That is also oxidizing. That's the zinc over there. So in both cases, the bonded metals are oxidizing, and the metals closer to the negative, closer to the source of the electrons, is what's oxidizing. This guy still is oxidizing somewhat. Now, much slower than my bonded metals, but it's still oxidizing. So I think the conclusion here is that, well, the conclusion is that hot marinas are just bad, because no matter how you have your boat, you're going to have more oxidation, look at that, than in an isolated cove, either bonded or not bonded. These guys are just, nothing's happening. The weird thing is that we saw yesterday, if your bonded circuit isn't in line, if it, for example, it's going across the path of the electrons, if it's perpendicular, you're not going to get oxidation, or at least, you know, your anode will probably work properly. So as a practical answer to the question, should you or should you not bond inside a hot marina, the answer is, well, it depends on whether or not your boat is oriented with the flow of electrons. How can you figure that out? I have no idea. So unfortunately, it's proving that one theory is right, but is that practically something to worry about? I have no idea. Okay, thank you.